Good morning, children. I am Mrs. Javeria, taking physical science for class 8th. We are into the second session of Unit 9, Electrical Conductivity of Liquids. In our previous sessions, we had seen the electrical conductivity of liquids and also electrical conductivity of solid materials. Okay, children. So the substances which allow current to pass through them are known as conductors, and the liquids which allow current to pass through them are known as electrolytes. So let's see the electrical conductivity of electrolytes. Take same amount of distilled water in three different containers. Dissolve small quantity of common salt in the water of the first container. Dissolve copper sulfate in the other and lemon juice in the next, that is in the second and third containers respectively. Use the tester that we used in the previous activity of electrical conductivity of liquids and record the observations in the table. Here you see the electrical conductivity of liquids, the second activity which we had performed in our first session. So here also we are going to take an injection bottle cap, rubber cap that is, and insert two pins and connect them to an LED in a cell. When we just connect, that is fix these two together or let them join together, we see that if the liquid is an electrolyte, the LED glows. So now in this activity what we do is, we all know that distilled water does not conduct electricity because distilled water is free from all salts and minerals, acids, and it is a poor conductor of electricity. So in this activity we'll add salt or copper sulfate and lemon juice to the distilled water. So when we had taken just distilled water in the injection cap, we see that the LED is not going to glow. But when we are adding a pinch of salt, then we see that the LED glows. Since the LED is glowing, it is a good conductor of electricity. That is, distilled water added with salt is a good conductor of electricity. Now in the next step, what we do is we add copper sulfate to distilled water, and here also we see that the LED glows, and hence it is also a good conductor of electricity. And the last step, we add lemon juice to the distilled water. When we are adding lemon juice to the distilled water, then also we see that the LED glows. Okay, children. In the first case, when we had taken only distilled water in the injection bottle cap, we had seen that the LED was not glowing since it is a poor conductor of electricity. When we added salt or copper sulfate or lemon juice to the distilled water, we saw that the LED glows, which proves that all these three, that is when salt or copper sulfate or your lemon juice are added to the distilled water, they serve as electrolytes, that is they are conductors of electricity. Now coming to the chemical effects of current. How do we study the chemical effects of current? For this, let's test the effect of electric current on a potato. We have taken a potato and cut into two halves, and we have taken half of it. Construct a tester with LED bulb. This is an LED bulb, this is a cell, this is a potato, and these are your connecting wires. So we should see that we are inserting these two copper wires of the tester into the potato, leaving around 1 centimeter space between them. You see here there is around 1 centimeter space between these two wires. Okay, once you have inserted it and connected the circuit, leave the inserted wires for 20 to 30 minutes. After 30 minutes, we observe that a greenish blue spot is seen on the potato around the wire connected to the positive terminal. Here this wire is connected to the positive terminal. Okay, children. And why is this change occurring? This is due to the chemical change in the potato, a greenish blue spot appears on the potato around the wire connected to the positive terminal. Okay, children? And I hope you all remember this is an LED which has two LEDs, a longer LED and a shorter LED. The shorter LED of an LED is always connected to the negative terminal of the cell or a battery, and the longer LED of the LED is connected to the positive terminal of the battery. You see here, children, this is a circuit and it is going and getting connected with the positive terminal of this cell. Here this is a cell. In a cell it is represented by two parallel lines. The longer line will represent a positive terminal and the shorter line will represent the negative terminal. So I hope it is clear for you all the chemical effects of current. Coming to the assignment, first question, what is an electrolyte? Second one, expand LED. And the third question is, give examples of electrolytes. I hope you all remember what is an LED. Here also we had connected an LED, and even in our previous activities also we had connected an LEDs. LED is light emitting diode. Clear, children? Okay. Thank you.